right, let's get started. Okay, so the first grades have come out. So if you look in Canvas, you see your grade on PS1. If you look on Gradescope, you also see it there. There's a little bit more detail on Gradescope. So on Canvas is just the number. On Gradescope, you can get an idea of why your grade is what it is. So look on Gradescope. If you believe that we made a mistake grading, which does happen, the way to do it is to do it through Gradescope. Gradescope has a regrade feature, so you can ask that an aspect of your grade be reconsidered. Don't misinterpret that. It doesn't mean you get to redo the assignment and have it regraded. It means that you can ask that some piece of your previously submitted work be graded again, be looked at again because you think a mistake was made. If you also see lab section grades. You know, you get 1 or 0 depending on whether you attended or not. If that is misrecorded, if you went to lab and it wasn't recorded, let one of the 2 TAs that run your lab know about it. And I want to point out that there is an incredible amount of help available that is not being taken advantage of. So if you find yourself struggling in the class or even just having a few questions, it is really easy to get help. And to do that, you go to the main page, click on Help, and it'll bring you here. And this is the schedule right here for the drop-in consulting. So during those hours, the TAs are up in the CADE lab, right, second floor, right across the courtyard, a lot of the time. So like today, they're there from 9:45 until 3, and actually I didn't update that. They're available some after as well, so I need to fix that. You guys remember when you're there after class today? I can check. Let's see. They are there from 4:45 until 6. So I'll fix that. Okay. I just see. Okay. So anyway, they're there a lot, and you can get TAs will come over to your computer, put yourself in the TA call queue. They'll come help you with your questions, and there's also available appointments. So what's next up there is called the one-to-one consulting schedule. So during the times that are shown right there, from 10 to 3 on Monday and so on, you can make appointments in advance, half-hour appointments with a TA. Last I looked, about 4 people have taken advantage of that this week. But you can make the appointments at any time. And the idea there is, if you're on the queue getting help, sometimes the TAs don't have enough time to help you for more than a few minutes at a time, depending on how many students need help. But here you get the full attention of a TA for half an hour. So take advantage of this. Okay? One thing students do is just go to the CADE lab and work on their homework there. And then when a question comes up, help is available. Any questions about this? Yeah?
How far ahead in advance do you have to sign up for
Okay, he asked how far in advance you have to sign up. There's no restriction. So you can sign up 5 minutes before the half hour. Yeah?
Would there be a reason for why my grades show up on both the PS1 and PS2, but on Canvas they say like missing on Canvas? Like they're grade numbers, but not on that.
Well, yeah, I don't know. If you'd send me a note on Piazza, I could look into it. It's supposed to be automatic. I just push a button and they get moved over. Any other questions? Right, the first thing I want to do, it's not that, it's this. I want to look at the assignment that was due last week and talk about it a little bit. So for example, here's one that we got a lot of questions about. you're given two dates in string form. So where you might get 09-09-2019, which is today. And you get two dates in that format, and you're supposed to write a method that will tell you is the first one, is date 1 earlier than date 2, true or false. And I gave you a hint that you could rearrange the dates so that it would work to compare them with compare to. So the idea is to put the dates into some form so that you can basically use alphabetical order to decide which comes before the other. So it's helpful to know that in alphabetical order, 0 comes before 1, which comes before 2, which comes before 9. Now, suppose you're not sure how compare to works, which I say you're supposed to be using. What should you do?
Google it.
Well, you could Google it. You'd get a long explanation. What's something else you could do? You could read about it in the Xi book. Sure. What else? Yeah.
You could convert the string into an integer, then do less than or greater than using the years.
Okay, well, but he's suggesting another way to do the problem. But what do you do if you don't know how compare to works?
You could hold your mouse over compare to.
Right? You can see the documentation by putting the mouse over compare to. What if you've read the documentation and you're still not sure what's going on with compare to? Okay, the answer is you experiment. I see all too many students that ask me, in Piazza usually, what's wrong with this code? And I see right away what's wrong with it, and they would have too if they just experiment with the pieces. So let me show you what I mean. If you don't know how compare to works, you've read about it, but you're not sure of the fine points, you come and you say, okay, let's try A, B, C, and we will compare that to D, E, F. I didn't mean to hit a new line there, but it doesn't matter. I've got to go type it right. Okay, so you take a string, dot, the method is compare to, and then another string is a parameter. And it's okay if they're literal strings, don't have to be variables. So what should that tell me? Is that true or false? Okay, well, it's not true or false. Is it negative, 0, or positive, I should say? Why is it negative? Because A, B, C comes before D, E, F in alphabetical order. So then you might say, oh, what happens if I'm comparing dates? And so you might say, okay, what if we do 02, 2000, and compare it to 01, 2019. Okay, so those are the dates you've got to compare, and I suggested you use compare to, so let's see what that is. So that says 1. That means that it's telling us that in compare to order, that first date comes after the second date. So you do this, you get some insight in how compare to works. Why do you suppose it is that it tells us that 02, 2000 comes after 01, 2019? Yeah?
Isn't it working like left to right? So 2 is greater than 1, so.
Yeah, it just compares the characters in the string left to right. So up here, it compared the A to the D. A comes first, and so that's the end of it. And this first string is less than the second string. You get a negative number. Down here, it compared the zeros. They're the same. So to break the tie, it compares the 2 to the 1. 2 comes after 1 in alphabetical order. The correct term is lexicographic order. It's a generalization of alphabetical order. And so it reports that the first string is larger. The first string comes after the second string. So once you see that, then you start thinking, okay, how could I rearrange the dates, write them in a different form, so that the date ordering would correspond to compare to ordering? Clearly, if we start with a month, that's no good. What's the most important part of the date? I mean, what's the first thing you want to look at? The year. If the year comes earlier, then you don't need to look at the month or the day. So instead of doing month, day, year, we need to do something like 2000, That's the year, that's the month. I should have used a different day. Let's do 03. And then we can compare to 2019, 01, and I'll make it 03 as well, just so you can tell the difference between the month and the year. So there we are in date, in year, month, day form, and this time it's going to tell us negative, which means that the first date comes before the second date, which is what we want. We want to get compared to do our work for us. Yeah?
Is it at all bad to have just kind of like negated the hyphens there when we wrote this method?
I mean, to get rid of the hyphens?
Yeah, when I just made substrings.
Sure. If we got rid of the hyphens, this would still work, as long as you got the date first, and then the month, and then the day. If you do, I'm sorry, the year. If you do year, day, month, it won't quite work. You need year, month, day. Okay? So now the problem is, how do we rearrange strings? And I suggested you use Substring. But if you don't quite know how Substring works, it's just experiment with it. So for example, let's go back to this one, 02, 03, 2000. Suppose you've got to pick out the month part. Okay? I saw a lot of students that asked this question. They had this in their code. To get the month part out, they did this. Okay? No, they didn't do that. They did this. They did this. Okay, they said, okay, I'm going to take the substring. I'm going to begin at index 0, and I'm going to go to index 1, and that'll give me the O2 out. They just want to pull the O2 out of that thing. And the program wouldn't work, and so they ask, why doesn't my program work? Well, what is the problem here?
It just takes one.
What's that?
It only gives you the 0.
Right? It only gives you the 0. So what Substring does is you give it the beginning index, and then you give it one bigger than the ending index that you want. Basically, you take the beginning index, which is 0, and you add to it the number of characters you want. So we want 2 characters, so we need to go 0, 2. So if we do 0, 2, you get that. So I'm not trying to pick on people that ask questions. I'm just trying to make this a learning, a teachable moment. If you've written your program like that and it doesn't work, what should you be doing? Besides asking a question and waiting for the result, waiting for the answer. What's another strategy? Yeah.
Try plugging something else in.
Yeah, just try it out. You might ask yourself, am I really pulling out the whole month? And just sitting there and staring at code isn't going to answer the question. Try it out. Use JShell. If JShell doesn't work, you can do the same thing with a main method in printing. It's just a little more awkward. Okay? In fact, when you're constructing your program, why not do it this way? Figure out what the pieces are, and then you put it all together. So how do we get the day out? Yeah? Okay, 3, 0, 1, 2, 3. Yeah, but it's 3, 5. And then how do you get the year out? You could go 6, 10, or you can just say, if you just give one parameter, it just goes from index 6 to the end of the string. Okay, so you can get those pieces together. Now, once you've got the pieces, how do you recombine them into a date that compare to likes? Okay? What's that?
Return the substrings, but then put the pluses in between so it combines them.
Right, so you just do something like this. I'm just using, this is just JShell, it's called that first, the answer to, $8's the answer to the last substring. So we do $8 plus, hyphen, plus, which was month, the $6, and then $7. That puts the string back together in an order that we know now that compare to can deal with. So once you've done all this, then you're ready to write the program. This won't get it done. Coming right here, deleting that and staring at it won't get the job done. Kind of hard to fill in the blank. You need to play with the pieces, get the pieces to work. And let me tell you something else that also won't work, is coming here, deleting that, saying, I don't know how to do this, I'm going to do another one, and then you solve this one, and then you submit it to Gradescope, and it won't even compile. Why not? I created an error right here when I deleted the return statement, right? If I look at this, it's going to say, this method must return a result of type Boolean. It doesn't return anything. So just be sure you don't corrupt the entire, ruin the entire, you might get 9 methods right, and then give up on the last one. At least make sure it has a valid stub so that it'll compile, so we can test the rest of them. Okay, so now what should we be doing up here to solve the problem? Given now that I've worked through the pieces, let's put date 1 in a different form. Okay, how do we do that? Okay, so I want to get date1.substring of 6, that's the year, and add that to, I'm going to leave the dashes out. The hyphens don't matter, really. I mean, if it says 2000-02-03 or it says 2000-02-03, it doesn't really matter. It'll compare the same way as long as we're consistent. So I get the year out, and then I get the month out. And the month was 02. And then what was it? 35. All right, and you might look at that and wonder, does that work? How could you test that out? Just that line right there. Just go to JShell and do something like this. Let's declare a variable date equals 02, 03, 2000. Let's call it date 1. So we'll declare that, and then I should just be able to copy this down, if I can remember how to paste into here. Okay. And date 1 is what we wanted. So now you've got newfound confidence. And so you do this. This is another error I see a lot, by the way. Okay, I'll call that date 2. All right, what mistake did I just make? Copy and paste. I make these errors all the time. You copied and pasted and intended to modify, and so you go, I forgot to change this to date 2. I got to be doing that. So you change these, and then it doesn't work either. Right, we go modify date 2. Then we want to return true if date 1 is less than date 2 using compare to, and return false otherwise. So that means we got to do date 1 dot compare to date 2. That's going to, how can we tell if that's negative? I want an expression that's true when that comparison is negative. Yeah, so we test if it's less than 0, and then we just return that as our result. For example. Okay? And you could write it with more lines of code, but the fundamental answer is the same way. You just take it apart, recombine it, and then do a comparison. But more important than the answer here is the process. Get some ideas, try them out, experiment. When you've got a method and it doesn't pass the test, take the pieces in the method and try them out. Make sure that you haven't made a mistake, that the code is doing what you think it is. That's what JShell is for, so you can play around with small bits of code and get some confidence in them. Okay, any questions about that? I want to point something else out. So if I, let me run the test cases on this. Okay, so you see, we passed, hopefully we passed some of the tests. We passed all the is earlier ones and failed all the rest, or most of the rest. The thing is, I don't know if you've noticed this, but if you click on a failed test, like this one here, there's a failure trace down here you should look at. I'm trying to make this big so you can see it. Actually, let me. What it tells you, often it'll tell you what it expected as the answer and what it got as the result. So what it's saying right up here at the top, it's too small for most of you to see. It says it expected some big long number. This was a test that did add numerals, 7, 4, 7, 8, and so on. But what it got was an empty string as the answer. Now, you won't always see that. Depends on what kind of assertion I make in the test case. It'll also show you which, if you double click here, it'll show you which assertion failed. So we can come over here and say, okay, I was adding these numerals and I was supposed to get this answer and I got the empty string. So you can get information other than, oh, I passed the test. It's not a binary thing. You can figure out what's going on. And in the lab tomorrow, you'll start learning how to use some of the debugging facilities in Eclipse that makes it even easier to figure out what's going wrong with your program. Okay, let me get rid of that and go to the next thing. Right, last time we talked about accumulation loops. I want to return to them briefly. We started with enumeration loops, so I guess I'm returning to it briefly. This is what I call an enumeration loop on an interval of integers. And all I'm trying to capture in an enumeration loop is what code you have to write to step through one after the other all the integers in some interval. In particular, the n integers that begin with start. So we're not worried about what we're going to do with the integers. It's just we need some systematic way of stepping through the integers. And that's what happens here. We set I to start, and then as long as I is not bigger than start plus n, we do whatever we need to do with I, print it out or whatever, add 1 to I, and then the loop continues. So that's sort of the minimal code required to systematically assign each possible value of I to I. So it gets start, and then start plus 1, and then start plus 2, and then start plus 3, until it's done in different numbers. So that's an enumeration loop, and it's a basis of all the other loops we're going to see. So here's the deal. When you write loops in any language, at first, every loop is an invention. It's a little invention. You got to use some ingenuity to figure out how to do it. As you get experience, you start to say, oh, this loop is just like 10 other loops that I've written in the past. And you sort of learn the pattern, and you spit it out pretty quickly. So I've gotten to the point where it's very rare that I've got to write a loop and I haven't written something very similar to it before. Sometimes I got to stop and think, this is kind of an unusual little trick, unusual little problem, and I've got to invent some little trick. But your goal ought to be to make the process of writing loops and methods in general kind of rote. And the way I'm trying to help you do that is by showing you patterns that come up, very simple patterns that show up a lot, that'll cover 99% of the loops you'll ever need to write. So this is how you chew up an interval of integers. That is how you iterate through all the characters in a string. So we set I to 0, and while I is an index into the string, so 0 is the first index. While I is less than s.length, we do something with the character stored at index I, and then we add 1 to I. And we just repeat that over and over again. That will march through a string, and you can do whatever it is you need to do with the string. This is how you go through a scanner. You say while scan.hasNext. You do something, you call scan.next, you get a string, you do something with it, and continue. So that's enumeration loops. It's the basis of the other three types of loops we're going to look at this week. And just to remind you, that's the first one we looked at. This is what I call an accumulation loop. And the way to look at this, just ignore the yellow code. Look at this white line here, this white line here, this white line here, and so on. What is that? Where have you seen that before? That's just the code from the enumeration loop. And to it, we've added the yellow. And so to turn an enumeration loop into an accumulation loop, so remember what the accumulation loop is going to do is something like add up all the integers or multiply together all the integers. We add the three lines of yellow code there. So we declare an accumulation variable, which I called ACC in this case, and initialize it. Each time through the loop, we combine ACC and I in some fashion, and we're all done, we return ACC. So you add those three lines of code to the accumulation loop, to the enumeration loop, and now you have an accumulation loop. Here is an accumulation loop on strings. Again, the white is the prototype for enumeration loop on strings. The yellow code that I added is the same yellow code I added on the last slide. Okay? See those three yellow lines of code? I'm sort of ignoring the header for accumulate. Exact same three lines of code are added to a different starting point. Same thing goes with accumulation loops on scanners. We add those three lines of code. So when you got an first thing you got to do when you got a problem is recognize, that's an accumulation loop. Then you know it's going to look like, depending on what you're iterating over, it's going to look like one of these three patterns. And the sooner you get comfortable with that, the easier it is for you to program. So let's go look at some of this code in action, because looking at pictures on slides is one thing, but we want to look at what's going on. So let me drag this out of the way. I'm going to have to make this work, I need to do a little change here. So just want to reset that. All right, so we're going to look at accumulationloops.java, and here's a method that we did last time. It's called product. And I'll tell you what I'm going to do. Move this over here. I'm going to blow up the screen this way. I'm going to get everything on the screen because I kind of got to make. This interface is a little bit tricky, so bear with me. Okay, that should do. Right here was our method product. And you should recognize an accumulation loop. It's supposed to multiply together all the integers from start. It's supposed to multiply together start plus 1, start plus 2, start plus 3, all the way up to start until it's multiplied together in integers. So that just follows the pattern we just talked about. There's the accumulation variable being declared. Here is where we combine the accumulation variable with the current value of I, and here's where we return the answer. So that's an accumulation loop. What I've done over here is I double click, and that creates what's called a breakpoint. And I'll show you why that's important. Up here in the main method, main is going to call product before it calls the other things down there. So it's going to ask for the product of 2, 5. So it's going to ask that 2, 3, 4, 5, and 6 be multiplied together. Now, you'll be learning about the debugger tomorrow, so you'll learn about this stuff. But if I click on this to start it, rather than click there, which how you usually run a program, I'm going to click on this little bug to debug it. So it starts at main and it runs. It asks me, do I want to switch to the debug perspective? So I'm going to say yes. Whenever I'm debugging, I want the debug perspective. And what it does is it runs like normal, but if it hits a breakpoint, I double-clicked on the line and made that breakpoint out there. It stops. So it's run, the program is run up to the point where it gets to that line of code. Now over here, there's a window that displays the value of the variables. So look on the right and tell me what parameters were passed to product. Remember, product has those parameters start and end. You see them declared right here. What were the values of those parameters? Look over in the window on the right. Shouldn't be hard to tell me. 2 and 5. Right? And we already saw that. We expected that. So now, if I click on this guy right here, which is step over, or F6, it's going to go to the next line of code. Okay, and you notice product just showed up. It was just declared, and it's a 1 now. So now there are 3 variables being dealt with: start, end, and product. Okay? Now, what's going to happen when I click step over again? Right, I shows up with an initial value of 2, because start's value is assigned to I. Now it's going to test, is I less than start plus end? Well, is it? It is. 2, I is 2. You look to the right and see I is 2, start plus end is 7. It's less than, so it's going to go into the body of the loop. Okay? Product gets product times I. Well, what's product times I? 2. So that's going to get stored in product. So look over there on the right, you'll see product turn into 2. And it even highlights it to show you that it changed. Now it's about to add 1 to I, so I'll do that. See, I becomes 3. And now we're back at the test. Is I still less than start plus end? Okay, now it's going to say product times I. This time product times I is 2 times 3. So that's going to change it to 6. And it'll add 1 to I. Okay, it's still the case that I is less than start plus end. Now it's going to multiply 6 times 4 to get 24. It's going to add 1 to I to get 5. It's back at the top. 5 is still less than 7. So we multiply 24 times 5 and get 120. Add 1 to I and get 6. I is still less than 7. So it's going to multiply 6 times 120 to get 720. It's going to add 1 to I. What's going to happen now? I is 7. Is 7 less than 2 plus 5? No. And so when I say step over, the next statement it executes is that return. So if I execute the return statement, you can see right here that product returns 720. And we're back up here where we called product from. Now if we continue from there, it'll call reverse. And then it'll call total length. But I didn't have breakpoints in there, so it just, we don't see what's going on inside those methods. So what I just showed you is, to understand how a loop works, you can't just look at it printed on paper. You've got to be able to sort of do in your head what I did with the debugger here. To think about the process that unfolds. So a series, when this loop runs down here, there is a series of assignment statements and tests. So that test and these assignment statements get executed one after the other repeatedly. And as that's happening, the values of the variables are changing. So it's not like you're doing exactly the same thing every time through the loop. You're doing the same assignments, but the numbers, the values that are being assigned change because the variable values change. So to understand loops, you've got to be able to understand, you should be able to predict exactly what's going to happen when you step through like that. Right? Well, we never, let's see, we didn't, okay. Here's reverse. We didn't implement reverse, but last time in lecture. So the idea is it takes in a string S and it's supposed to return its reverse. So like if it gets A, B, C, D as a parameter, it should return the string D, C, B, A. So I want to think of this as an accumulation loop. We're going to build up the reverse string and return it in the end. Now, what code do I have there? This code right here that I'm about to highlight. How would you describe that code? Yeah, sure, it goes from left to right through the string. But there's a term you could describe that code with. You've seen that code before. That's an enumeration loop for strings. So that's our starting point. And to turn it to accumulation loop, we need to add three things. We need to declare the accumulation variable up here. We need to update the accumulation variable here, and then we need to return it down here. Okay? So this is where you start to have to get creative. It's not hard to declare the accumulation variable. Let's just make one up. We'll say string result, and I'm not sure what we'll initialize it to. But once you decide you're going to call that accumulation variable result, you know that's what you're going to return down here, usually. So what's left is what should be the initial value of the accumulation variable, and how do we update it each time we see a new character as we go through. So marching through a string from left to right, how do you produce a string which is its reverse? Yeah?
Use substring in the string.length.
Well, we don't need to use substring. We can use char at. Char at will tell us what character is at index I. Well, let's see if I can get this to work. Okay. Remember exactly how to erase. That's it. Erase all ink. Okay, let's suppose you have the string A, B, C, D, and you want to reverse it by going through the string from left to right. And produce, as you go through from left to right, you're going to accumulate a new string, which is the reverse of A, B, C, D. How would you do it? Suppose you had to do it on pencil and paper. That's one way to think about it. You're only allowed to see one character at a time. What would you do? Yeah?
Like char at the length of the string minus I being the...
Well, what would you do? Let's say you're going from left to right and you have the character A. The first character you see is A. What should you do with it? Let's create a string. Let's add it right there to a string A. Now we go to the next character, which is B. What do we do with it? We stick it before the A, right? Then we encounter the C. We stick it before the B, and then we encounter the D, and we stick it before the D. So basically, we build the string with the characters we encounter, but we always make the next character we encounter the first one in the string we're building. All right? So as we move left to right, we're building the string up from right to left. All right? So how do you build up a string? Well, let's say you're building up a string. What do you start with? What should the string look like before you start the reversed string? Start looking. What should it look like before you start adding any characters to it? Yeah, just be an empty string. And then each time through the loop, we're going to find a character. I'll break it out like this. What should we do with C? How should we combine C and result? Yeah?
Assign result to C, add to the result, or combine to the result.
All right, we just append C to the beginning of result. Yeah?
How would you do it if the string has space, like the incrementer?
Say it again.
You know the incrementer
Mm-hmm.
The initial string has like spaces. How do you account for that?
The initial string has spaces. They just go into the reverse string as well. If the original string is A space C, the reverse string will be C space A. Space is just character like something else. I'm not saying letter, I'm saying character. Well, do you believe this works? I mean, there's such a thing as proof by intimidation. You know, the professor says it works, therefore it must. But what if you go home and you say, man, I don't understand how that works. He said it works. We could run the test against it, but that still won't tell you why it works. So what could you do?
Use that debug.
Yeah. Use a debugger and just step through it and see what happens. Okay, so I'm going to remove this breakpoint right here because I don't want to mess with, we already dealt with that. And I'm going to set the breakpoint on the first line. And then I'm just going to, I got to get a little more space here. Then I'm just going to run my program by clicking the bug. And what happened?
If you have another breakpoint higher up,
I thought I took it out. Well, I don't know where I'm stuck. I'm going to click here to continue, and then it ended. All right, something happened where it didn't highlight that code. Let me try again. Okay, so yeah, something, I don't know what happened there. But. So here we are in reverse, first line of reverse. What was the parameter passed into reverse? You look over here, look on the right side, it says the value of S is currently A, B, C, D, E, F, G. That's the string that was passed in. Will S ever change? There's nothing in this code here that changes S, so we shouldn't expect that to ever change. So we'll start by setting result to the empty string. Okay, result's the empty string. We're going to set I to 0. Is I less than the length of S? Yes. So we pull out the character C. So what should we get when we ask for the character at index 0? A. You see it there. And then we do the append. We append C to the beginning of result. So what will result be after we do this operation? It'll just be the string containing A. And then we add 1 to I. I is still small enough. And we grab the next character. So now we're doing s.char out of 1, which is B. And we're about to append B onto the beginning of result. So what will result become? BA. So you may have been wondering, why do I stick the character at the beginning of the string instead of the end of the string? What would happen if I said result equals result plus C? I'd just be making a copy of the string. It would be A, B, C, D, and so on. This way, I build it up backwards. I get a reverse string. And so, not to belabor the point what's going on, I'll just step. So now C is, this time through, C is C. C is the character C. I append, I get CBA. I goes up to 3, so this time character C is D. The append is DCBA. And round we go. You can see result building up. And it's going to stop. Okay, I is now 7, which is the same thing as the length of the string. So it should, the loop should end. And it's about to return result. And you can see that it returned G, F, E, D, C, B, A. So if you've written the loop and it's not working quite right, one thing I encourage you to do is do what I did here. Just step through it. Look at the variables. See what's happening. See if what's happening is what you think. Sometimes you spot the problem right away that way. Okay. Any questions I could answer? Yes?
So like for loops then, would you recommend using the debugger instead of JShell? Because like JShell doesn't exactly show you.
Okay, so he's asking about should you use a debugger instead of JShell. So my advice is, if what you're doing is, what you want to do is experiment with expressions, or maybe a couple simple statements, JShell is the thing to do. If you want to if you want to use a debugger, unfortunately, the debugger doesn't interface with JShell. So I tried to fix that once and I didn't succeed. So to debug existing programs, yeah, you'll have to use the debugger. And the trick is just in the main method, put a call to your. So if you want to figure out reverse, you don't need this other stuff. So we'll comment that out. Just put in a call to the method you're trying to debug and then step through it. And if you don't remember how to step through it, well, you can look at the video. Also, you'll learn more about it in the lab tomorrow. Okay. Any other questions? All right, let's take a few minutes off, and then we will look at some more examples. All right, now, at this point, I want to write a few methods again. I'll write some more accumulation loops. And unfortunately, I'm here in sort of, Eclipse tries to figure out what you're doing. And if it knows you're debugging, it brings up what's called the debugging perspective. And so you see different windows here arranged in a different way than you would if you were using, if you're in a different perspective. So the thing to realize is up here in the right-hand corner, that's the Java perspective. I don't have the mouse over right now. Then there's a Java browsing perspective. There's a debug perspective. So I can go back to the Java perspective just by clicking up there. Now it's still got them kind of. Okay. Now the windows that were there before are there. Or you can come up here to Window Perspective. You can pick what perspective you want to open. Or if there's a particular window you want that's not available in that perspective, you can come to Show View and you can pick a window. So If you screw up the perspective and you yearn for the good old days when Eclipse looked like it was supposed to, you can come here to come here to Window, Perspective, and Reset Perspective, and that'll put it back to its default form. Like, I don't like task list and outline for lecture just because I need more space, so I just kill those down. Okay, here we are. We've written loops, so we did this last time, product. We just did reverse. We did total length last time. So we have done an accumulation loop that consumes a scanner. We've done an accumulation loop that consumes a string. And we have done an accumulation loop that consumes an integer interval. Those are our 3 examples. PS3, which is due Thursday or Friday with a late day, has some methods that will involve writing loops. All of them involve writing accumulation loops. And they either are accumulation loops over intervals of integers, or they are over strings, or they're over scanners. So this is absolutely relevant to the assignment. All right? So let's see what you do. It says returns a string containing the n integers beginning with start, all appended together. Okay? So if start is 1 and n is 10, what string should come out? Okay, we're going to append together all the integers in an interval. Okay, so suppose I want to append together the 10 integers that start with 1. Starting with 1, append together 1 and the 9 integers that follow.
So it'd just be all those integers smashed together.
All the integers smashed together. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in a string. Okay? So that sounds like an accumulation loop because I'm combining all the integers into one thing. That tells you it's an accumulation loop. So, how would you get started? It's sometimes scary to look at a completely blank method body and not know how to get started. So if nothing else, I want you to go home today knowing how to get started. Yeah?
Is there a string appended variable?
Okay, so, so that question, you're thinking about what am I doing inside the loop? I want to think at a slightly larger level now, before we think about details like that. Just knowing, forget about what this method is supposed to do. Knowing that it's an accumulation loop that consumes an integer interval, what should that tell you to do?
Paste in some generic.
What's that?
Paste in some generic accumulation.
Yeah. Paste in, just start with an accumulation loop. So go find the loop from lecture or the book or your previous work that's most similar and paste it in and then work at it and then modify it from there, because at least it's going to be in the right structure. So you got to find an accumulation loop over integer intervals. Where can we find such a thing? Where have we seen one before? Where have we written one before? Right there. Product was an accumulation loop. So let's just copy this. Now this isn't exactly what we want, but its structure is correct. The names might not be right. Let's paste it in and see what we've gotten. So I'm going to comment out the parts that are, first of all, why was I able to paste it in with very few compiler errors? Yeah?
Because the variables that are being stated are within the scope of that method.
All right, so in other words, this method is taking these parameters start and end. The place I copied from also had 2 variables called start and end. So we're lucky. If this method had used different variables, I'd just have to rename things. Okay? But why is there an error here? Why is return product underlined in red? Right, product is an integer and we're supposed to be returning a string. So the thing is, all right, to make an accumulation loop, you've got to declare the accumulation variable, you've got to update the accumulation variable in the loop, and you've got to return the value of the accumulation variable at the end. Now this is a very different problem, and so those lines of code are going to be changed. So I've commented them out. What's left when I comment them out? An enumeration loop. And that's still fine. And it worked, no changes are required here simply because start and end, like I mentioned, were called the same thing in the program I copied from. So I now have a program which I've got the correct enumeration loop. I've got the correct places to insert the code to make it into an accumulation loop. I just got to decide what I should replace them with. So I'm going to be building up a string that consists of all the integers in the interval mashed together in a string. So what accumulation variable do I need? First of all, what type should the accumulation variable be? Okay, it's easy to see. We're producing a string. It says right there, string. So we need to return a string. Now, if I can't think of a better name for an accumulation variable, I'll just do result or something. What the heck? And usually, not always, what you want for the initial value of your accumulation variable is some sort of identity thing, an identity value. So if you're adding things together, you want 0. If you're multiplying things together, you want 1. If you're appending things together, what do you want? An empty string. So that's just saying we'll start out with an empty string. When we're all done, that variable will hold our answer, which we need to return. So that's easy too. So all that's left is, each time through the loop, what do you do with I? How do you combine I and a result? It's going to be result equals something new. Yeah, so we take the current value of result and append the current value of I to it. And that's that. Obsolete methods, what the heck? Oh, the problem was the program was still running. So there are some circumstances where Eclipse will let you modify. And when you're debugging a program and you hit a breakpoint, you can actually modify the program and continue debugging. But sometimes that causes problems. That's what you just saw. The solution was just to terminate the running program. Okay? So, you think this works? Let's do this. Let's reload the project in here, so I got it. And then it's called Accumulation Loops .appendInts. And I'm going to pass it in 1 and 10. So we should get back a string containing 1 through 10. Oh, okay. The problem I'm having here is I didn't run JShell on. Let me rerun JShell. Okay. Project Explorer, this is where I am. We'll launch JShell. Okay, so there we got it. And once you've typed it once, it's easy to, let's go from 50 to 100. No, it's not from 50 to 100. That's starting at 50, use 100 integers. So the first one is 50 and it ends with 149. So that's 100 integers beginning with 50. Or if you want to see how the process unfolds over time, what do? What's that? Debug it. So I'm going to double click here to set a breakpoint. Then I got to go up here and actually call the method. So again, I have the program still running. And let's see what it doesn't like. append ints. Okay, and then we should be able to do the debug. And I don't have it magnified right now, so you have a hard time seeing, but I can step through the code and watch what's going on. Now, you can look over here and see what the values of things are. You can also hover the mouse. So like I can hover the mouse right here and see result is currently 123. And then I can step over. Result is 123. I is 4. I step over. Now result is 1, 2, 3, 4. So it seems like it's doing the right thing. Okay, back to this perspective. Okay, here I got a method that takes in a string and it wants to return a string containing just the lowercase letters of S. So in other words, let's say we gave it A, B, C, D, E. What should we get back? So if we give it that string, I should get out A, B, E. Okay? So we're sort of, this is actually, again, this is intended to show you that sometimes writing an accumulation loop won't get you, you have to innovate a little bit. It's not always cut and dry, and this is a little bit different than what we've seen before. So how would you do it? Knowing that it's something like an accumulation loop, so where do we go for inspiration? Where do we find an example of accumulation loop that consumes integers, consumes strings? Let's see, we did it up here, right? That reverse. So let's copy that. Let's come down here. And this time we're, okay, S is called the same thing in both methods, so that's good. We're okay with a string. All right, we're going to return a string, so this works. Really, all that changes is right here. So each time we go through the loop, we're going to be looking at a character. What do we do with that character? Do we just append it onto result like this? What do you think? What happens if we write all lowercase that way? What's going to get returned? Each time through the loop, we take the next character and append it to the end of an initially empty string. Just whatever S was is what will get returned. It'll build a new string, same characters, and return it. But we want to only include the lowercase letters. If there are any uppercase letters, we want to throw them away. If there anything that's not a letter too, we throw away. So how can we arrange to include just some of the characters? Yeah?
Could we, for character C, could we say s.cat I dot to lowercase?
Well, I don't want to convert to lowercase. I want to throw away the uppercase letters. I want to ignore them completely. Yeah?
Use like an if else statement.
Right.
If
We,
it's in the range, include it, if else, like.
right. We just need a conditional. So if something is true, we're going to append C. What's the else? What do we do? Okay, well, first of all, under what circumstance do we want to append C to the end of the string? Yeah?
If char at this index is equal to uppercase char is equals to uppercase char.
Okay, well, yeah, you got the right idea,
No,
but
not equal.
basically, the circumstance in which we append C to the end of result is if C is a lowercase letter. If C is not a lowercase letter, we don't want to append it. So you just have to know that, okay, how do we tell if it's a lowercase letter? So there's an is lowercase method that'll tell you if C is a lowercase letter. So this is sort of a twist on a standard accumulation loop in that we don't accumulate everything. we ignore some things, and we do that with a conditional. So if we're dealing with a lowercase letter, we stick it on the end of the result. What do we do if it's not? We ignore it, right? So we do nothing. Now, what's a more succinct way of writing else do nothing? Just don't put the else. So that's saying if it's lowercase, do this thing, otherwise just go on to the next statement. So that would basically copy over all the lowercase letters into our result string, ignoring everything else. And again, I can look at this and tell that at a glance. I suspect most of you can't. Most of you can't. Some of you can because you've done this before. It takes practice to be able to look at code and go, oh, okay, I see what it's doing. Because I think when most people look at it, they don't think of it in terms of what does it do. They just look at it like you might look at a bunch of words on a page. And somehow expect the words on the page to tell you what's going on as time evolves, as the program runs. You've got to learn, you got to be able to do what the debugger does. You got to be able to figure out what's next and what's happening as the program runs. And don't be frustrated, it takes time. It may seem really hard at first, and eventually, though, it becomes second nature. So, the takeaway is, when you're working on PS3, and you get to your first method, and the first method is a conditional, but you go to your first method, it requires a loop. What should you do for inspiration? Look back at these examples. Pick one that seems closest. So if you're consuming a scanner and producing a string, come back here and find something that consumes a scanner, an accumulation loop that consumes a scanner. Use that as your inspiration. So that means you need to have this code copied over. Let's do another one. So this says returns the sum of the integer tokens in SCN, which is a scanner. We assume that it contains only integer tokens. So that just means that the scanner is going to the tokens are going to be integers with space in between them. There's nothing, nothing's going to be in there that we can't turn into an int. So we just want to add up all the integers in the token in the scanner. What kind of loop does that sound like? And we're adding up everything adding up everything, multiply together, append together, whatever. Those are accumulation loops. So we need to go look for inspiration. So should we look here for inspiration? All lowercase was an accumulation loop. Why is that not the best source of inspiration? Because it iterates over strings. We need to find something that does accumulation over scanners. So let's keep looking. That's not it. What about that? It works on a scanner, and in fact, it returns an int. So that seems promising. So we'll copy that code. And paste it in. And there are no errors. That doesn't mean it'll work. It just means that scanner have to be named the same thing, and we're returning the same type of thing as before. Okay, so this and this and this are the parts that distinguish this accumulation loop from some other accumulation loop. So to turn it into a different accumulation loop, we need to rethink the things I just commented out. So what would be a good name for the accumulation variable? What are we building up as our answer? Sum. So let's declare sum equals 0. And we declared it an int because why? Because that's what we're trying. We're trying to compute an int. And when you always know that whatever you declare, when you're done, you just return it as your answer. That's what you're trying to accumulate. And here we just got to update sum. How do we do that? Sum equals sum plus. And here's where, okay, something's a little bit different. Yeah?
You have to convert the s into an int and then you can add it.
Okay, so he's saying, okay, we hit this s is going to contain the next token, and we've got to convert that to an integer and add it to sum. How would we do that?
Next in.
Okay, so here's one possibility. We could just parse it. So you could parse that token into an integer. So if say that token is the string 57, we convert it to the int 57 and add it in. But there's a better way to do it, a simpler way, which you were suggesting. Maybe you're going to repeat.
Yeah.
Okay? Instead of asking for the next token as a string, you can ask for the next token as an int. So doing it that way, as long as you know the next token is an int, it will parse it for you. Now, so we're basically saying parse the next token and give it back to me. Parse it as an int and give it back. Why is it underlined in red? Let's see. Cannot convert from int to string. So basically, this is an int, and we're trying to store it in a string variable. So what's the fix? We'll just store it in a variable, and then do that. That's just going to spin through, sucking tokens out of the scanner until there aren't any left. And each time it gets one, it adds it into sum. So when we're all done, sum contains the sum of all the tokens in the scanner. So here, this file right here, accumulationloops.java, contains two examples of accumulation loops for integers, for strings, for scanners. Those are the only kinds of loops you got to write on the assignment. This is a good place to start. Okay. Any questions I can answer? We've got another topic I'm going to open up here that I answer questions. Yeah?
Back on the one where you were just doing the lowercase characters, this would be a less elegant method, but I was just wondering if for the if part, if you could have just actually specified the Unicode range for lowercase letters, would that work as well?
Yeah, if you happen to know the Unicodes for A and Z, lowercase a and z, you could.
Could you just set it if it's between A and Z?
Yeah, it would look like this. Yeah, you're right. You don't even have to know the Unicode equivalents. You could have done something like this. If C is greater than or equal to A and C is less than or equal to Z. That would do the same thing. But, well, I take it back. It wouldn't. It would do the same thing assuming that you're using the Latin alphabet. If you're using the Greek alphabet, it wouldn't work at all.
Oh, okay.
Because the lowercase letters in the Greek alphabet aren't between Latin A and Latin Z.
Oh, okay. So if you use the Java methods, it'll...
Right. That's a lot more flexible and powerful to do it that way. Any other questions? Yeah.
Why do we have string as the number of tokens?
Okay, which method are we asking? The one below here?
Yeah.
Okay, you're asking why do we... Okay, ask your question again.
So can we use some other stuff like integer instead of string there?
Well, where am I using string there? Yeah, that method doesn't mention strings at all. The reason it doesn't mention strings is when it gets the token out of the scanner, it's asking the scanner to convert it to an int. Now, if what the scanner contains is not an int, if the next token is not an int, we're going to an exception and the thing will crash. But any other questions? All right, now, we've looked at now accumulation loops. A lot of loops are accumulation loops. A couple more I'm going to teach you about, though. One kind is called a searching loop, and the other kind is called an optimization loop. So what does a searching loop sound like?
Just try to locate something.
Right. So given a string, find a character with a particular property. Like maybe, here's a string, give me the index of the first lowercase letter in the string, or the first white space in the string, or the first piece of punctuation in the string. That's a searching loop. Now, how's that different from an accumulation loop? Why does that problem sound different?
Because it's just combining stuff. It's actually looking for something specific.
So it's looking for something specific. So it's not combining all the elements in the string into one thing. It's trying to find just one particular character in the string, or one particular token in the scanner, or one particular int in an interval that has some property and then gives it to you. So that's different from an accumulation loop, because accumulation loop has to combine all those things into one overall value. Here we're just looking for one thing. Here's another difference. Does an accumulation loop look at every number in the interval, at every character in the string, at every token in the scanner? Does an accumulation loop have to look, does an accumulation loop ever end early, or does it run until the interval is exhausted? Right. All the examples we've done, it just runs as long as there, you see right there, while there's a token, keep going. While there's a character, keep going. While we haven't gotten through our interval, keep going. So accumulation loop looks at every single element in the interval. Does a searching loop need to do that? At what point can a searching loop terminate? Right. As soon as it finds what it's looking for, it stops. Okay? That's important. Imagine a giant document, a Word document, and you ask it to find a word. You say search for the word Joe. It doesn't, it just has to look until it finds Joe, and it tells you where it is. It doesn't have to look through the entire document necessarily, unless you ask for the next thing. So that's an important kind of loop, a searching loop. And the thing we'll see about the searching loop is there's a return statement in the middle. So from inside the loop, there's going to be a return that gets executed when you find the thing you're looking for. Now, let me tell you the other kind of loop we're going to look at. That's called an optimization loop. So an optimization loop is, here's a collection of things. Here is a bunch of characters in a string, or a bunch of tokens in a scanner, a bunch of integers in an interval. Find the best element. Find the best letter. Find the best number. Find the best token. So what could be some definitions of best here? Right, so find the longest token in the scanner, or find the shortest token in the scanner, or find the number in the interval with the largest cosine. So with optimization loops, there's always a superlative. Now, you're not combining all the elements into an overall element like an accumulation loop. You are finding a particular element, as in a searching loop. But what's the difference between a searching loop and an optimization loop? Yeah?
Doesn't an optimization loop have to go through everything,
Right.
and compare everything, and then return the best results?
Right. So an optimization loop is going to have to look at every element like an accumulation loop, because you never know where the best is going to be. You can't stop early unless you've seen them all. But when it finishes, it's going to return one of those elements. It's not going to return a combination. So it's sort of a hybrid, if you will. But between accumulation, searching, optimization, that covers a lot of ground. And if you can master those idioms, you're a long way to becoming a competent programmer. So we'll dig into this next time and look at those other two examples.